Good morning, good afternoon, and good evening to all of you who are attending this session today. Today, as Bella said, we will talking about street lighting and its deployment. Today you also will gain more insights into the advantages of smart street lighting systems, the challenges that it can bring, and the various deployment strategies. We will do that together with my colleagues Yong, Liang, and some Shekar. And this webinar will also provide you with enough knowledge to understand the benefits of smart street lighting. You will be able to identify the challenges of deploying smart street lighting, explore communication network options for field services, and discover key features to support deployment. And now, without further ado, I would like to hand over to Yong Liang, who will start this conversation between some. We are not using that many slides, so feel free also to leave your questions during the conversation. And with that, I will do the moderation to bring the questions into the discussion and the conversation. Thank you. Yong, Liang, you're at the stage.
Thank you, yeah. You hear me well? Oh, good. Thank you. So that's my profile. I think in the invitation of this webinar, you would have heard, read about it also, and that's the profile for SOM. I think we will not go into detail here. And yeah, first of all, thank you for joining us today, and allow me to share a bit about Signify as a start to this webinar. So first of all, Signify is a world leader in lighting. We offer the full stack in lighting, in light sources, luminaires, and systems and services. Overall, in the industry, we are number one, and the sales turnover last year was over 6 million euros, and we are present in over 70 countries. Some key indicators of our business and where we are focused on, you can see already on the top left-hand side. Let me just bring up the annotation so we can guide you through. All right. So 4.3% out of the 6 billion euro is reinvested into R&D, and that is growing. So we do have a lot of focus in spending on R&D. And sustainability is a big focus for the company. So you can see here already 35% of our revenues are in circular, meaning refurbishment of lighting products and luminaires. And we are also on track on the target for 40% greenhouse gas emissions reduction this year. And of course, you see on the right-hand side that there's also a big focus on women in leadership positions in the company. Already last year, we are almost hitting 30%. So that's already quite a large percentage across. And for connected, where we have digitized, in fact, most of our sales, we have over 150 million connected light points already by Q2 this year. So that is also counting. Okay, and our purpose overall as a company is to unlock the extraordinary potential of light for brighter lives and a better world. And one of them, of course, is connected street lighting, the topic of today. And specifically, we want to speak about simplifying deployment of connected street lights. So as a start, if you look across many city municipalities, utilities which manage street lights across, many of them are looking at digitizing their operations and management of public infrastructure. So many of them are looking for centralized control of systems that they can apply across public infrastructure, and thereby also to improve operational efficiency, streamline maintenance, and also fix faults and issues as soon as they can, and as soon as they are identified. With that, also there's a big focus on sustainability with energy savings by dimming the lights, by switching on and off very accurately. And finally, everything that they are doing and also plan to do would also come to ensuring that the livable spaces are improved for citizens, in that it becomes safer, and also the ambience around the city is much better for all the citizens in the city. And in particular for city municipalities, one of the low-hanging fruit that they are very quickly focused on is connected street lighting or smart street lighting. Some of the benefits are listed here, and needless to say, of course, right, when you deploy or decide to deploy a smart street light, you are essentially also looking at major energy usage reduction. And for us, the conversion from conventional street light to smart street lighting with LED could save up to 80% energy. And along with that, of course, the CO2 reduction that is also one of the big focus in sustainability for many of the city municipalities. Besides that, now that all the streetlights are managed and controlled in one application on a dashboard in a platform, then the operators could easily optimize their operations by using the data that is accessible in the application, and also then with the objective of reducing the maintenance and operational costs. Now that lights are monitored constantly in a platform with smart street lighting, certainly the uptime is better for all the lights. You can improve uptime and thereby reduce downtime. So with better lighting, the safety of road users, safety of citizens along the street and in the city will be improved. And there are also reports that have also shown that with better lighting, there is a reduction of crime by up to 20% and road accidents by up to 30%. So that is also one of the big benefits coming from conversion to smart street lighting. Beyond that, for the urban environment, streetlights are deployed across the city, right? So they are essentially assets around the city that is available in almost every corner of the city. Therefore, they are natural candidates for any kind of IoT sensors that you can deploy across the city with power that is available on the street light, at the street light. So therefore, one of the big benefits of smart street lighting is that you can also use these street lights to attach IoT sensors for, let's say, ambient noise or ambient temperature, even to also detect the lampposts which are unsafe, right, when it is tilted because of an accident, etc. So with that information, the operator and the city management team can also use those data to better manage the city and even plan and design the city much better for citizens. Across the city, we spoke about different applications that cities are looking at, and therefore smart street lighting is only one of the applications amongst the many. And as such, the application has to be open and scalable for many light points that are across the city. At the same time, security is a big focus, especially today, right, where there's a lot of security vulnerabilities that come on very often, right? Sometimes within 2-3 weeks, you have new security vulnerabilities. And therefore, cybersecurity is a big topic, especially for public infrastructure. So it's also important to ensure that these public infrastructure are well protected even when they are connected. Finally, there's a side point here, right, with energy saving capabilities by dimming the light, switching on and off very accurately, and also being able to select at different times of the day, at different locations of the city, to dim lights or to even switch off when there is limited use of the area. It could help to ease grid pressure. There are many locations around the world where the city or the citizens are subjected to brownouts, and with the capability to manage the public infrastructure directly from a remote central application, where there is a risk of brownouts where the grid could be switched off, this capability could ease some of the pressure. And this is also in the light of increasing energy use, electricity use at home, especially with the growth of electric cars and EV charging stations. It could become quite a big advantage by having streetlights connected. Okay, and in Signify, we offer two solutions, both connected smart street lighting, and here you see this Signify Interact solution, where it is a design award solution, right, with the user interface that we released a couple of years ago. Of course, it provides a centralized control, very open integration with APIs, also with some interfaces like top of fireware to third-party systems to smart city systems to have them all integrated into a platform. And of course, very scalable to global cities everywhere around the world. To date, between Talensa and Interact, these two propositions that we offer for smart street lighting, we connect almost close to 7 million streetlights already in the past 15, 16 years that we have deployed the systems. And we are also deployed across more than 60 countries. Here you see some of the project locations that we have deployed already across the world. So we are certainly not a newcomer to this business, and the connected light points and city that deploys and employ our solution is growing as we speak. Now, one of the key important element to connected smart street lighting is the communications networking infrastructure or communications infrastructure. These two charts here I'm showing is in fact coming from Northeast Group, which is a research analyst, and they have plotted out some of these common IoT networking infrastructure that is being used for IoT devices, including smart street lighting. The chart is a little bit, I wouldn't say complex, but there are layers here. So you can see there are unlicensed networking technologies and also licensed networking technologies. So licensed networking technologies are those of cellular networks, and they come in a form of 3G, 4G, 5G, which is what is common to many of us who are using mobile phones with cellular networks. What is not so common is the IoT networks, and here you have LTE-M or Cat-M1 networks, and then also the narrowband IoT, NB-IoT networks. So these are the licensed networks that are operated by the mobile operators. And licensed because these are the spectrum, radio spectrum that are sold to these mobile operators, and they manage them professionally to ensure quality networking between devices and also the applications. And as you can see in this table, in the x-axis, that is the range of the communication, and on the y-axis is the bandwidth. So certainly the license technology, right, with cellular connectivity are the ones with the furthest range or the largest range and also the largest bandwidth. But these come at a cost. So these are of course not free. These are licensed. There's a cost of operating it. So the mobile operators are collecting a fee for the use of these networks. There are also some of these unlicensed networks that are available for IoT devices. Listed here are the RF or Wi-SUN mesh networks, where there is relatively good range and also relatively good bandwidth. And then here you also see LoRa or long range with good range but much smaller bandwidth. And then you have the ultra narrow band, another form of unlicensed radio frequency where the range is very good, but bandwidth is rather small. On the right, you see what Northeast has indicated on the suitability of the network for smart street lighting across bandwidth, latency, range, ease of operation, and of course, operating costs. And here, as we mentioned earlier also, the top three are the licensed networks with cellular, and the bottom three are the unlicensed. And for me, I think these networks are all good, but what's critical is that it must be fit for purpose. For smart street lighting, where we have quite a bit of data throughput, data transfers between the end devices in the field, and also the application, actually on the daily basis is pretty talkative. We have these calendar switch points, dimming logs that are transported and backhauled to the application. Also fault information, energy information, and if there are sensors attached onto the street lights, there's even more data to be transported back to the application. So it's actually quite a talkative application with smart street lighting that would require a certain amount of bandwidth and latency. And of course, the range of these networks deployed will also directly determine how these smart street lighting networks are deployed across the city. And finally, of course, cost is an important element, right? These days, I think many of these large projects are certainly looking at a much better cost structure in the capex as well as in the opex of deploying such a smart street lighting solution. So with that consideration of networking infrastructure, today we will focus on the deployment of the smart street light in relation also to the selection of the networking capabilities. Okay, and with that, maybe I want to also at this point bring in my colleague Song, who is the product manager of the RF mesh proposition with Interact, and he has certainly come across quite a lot of challenges, I would say, in the deployment of smart street lighting. And perhaps, Song, you want to share with everybody, some of the challenges that you have seen.
Before we go into challenges and discussing about challenges, how we overcome, maybe I may ask you one question, Yong. So we are seeing different communication technologies on the left side, and also we are seeing how the communication infrastructure is there. So do you know what percentage of street lights in the field, in the streets, with the different communication architectures we see?
Yeah, today, based on all the research that we have seen, about 50% are deployed with RF unlicensed networks. About 50%. So actually, that's quite sizable. And potentially about 30% of them are on cellular. Cellular is growing based on what we have seen the trend past few years. But again, like we said earlier, it comes at a cost. So for customers in the selection of the networks, if quality of service is absolute important, then yes, they can consider cellular, but it comes with a bit more operating costs. But I think RF mesh will continue to be there and will continue to be growing. The fact that we have architected, or many of the vendors may have architected the solution with RF communication, particularly RF mesh, to be optimized for smart street lighting, having had all the experiences before also. So it's becoming also more and more robust in the way we architect the network.
Thank you. Thanks for that. So when we talk about challenges, right? So challenges for yeah. So we saw what is the difficulty in different infrastructures and communication technologies at the same time. And if we are looking at cellular, it's it's for every cellular means you need to think about a mobile phone and the street light, right? So every mobile phone has a connectivity with a full-fledged NB-IoT or CAT-M, or you can say 5G connection, but it's going to be a high and very costly to do. So most of our customers are moving towards low cost solutions with how they can do deployment of the streetlights. So we have unlicensed and licensed. So there are licensed which are costly and unlicensed which are going to be difficult in operation, but the cost of operation will be less, and the bandwidth also is there with us. So if we are talking about unlicensed technology and the cost of operation and deployment, these three are biggest challenges we see if we are talking about every street light in the unlicensed sector. They have to go to every street light and then collect the information because it is still unlicensed. The communication is not there with next to each other. So either we have to choose a star network or a mesh network or a LoRaWAN kind of network, type of network. So every street light, the installer needs to go and then collect information. Maybe he needs to scan a QR code of that street light, which is a unique for the luminaire, also a controller, and come to light management system, the central management system, give that information back, like this is my asset and these are my information of my controller and my luminaire. And then the central management system, the light management system, will start talking to those devices in the field. Also, at the same time, when he is collecting the information, he needs to also collect the electrical parameters. For example, what is the dimming parameters of that luminaire or lantern, or what is the wattage this lantern is going to be? Is it 30 watt or 40 watt or 20 watt, depending on the street? So we see different streets in the field, right? So you see parks has a different lighting infrastructure. There are roads, motorways has a different lighting infrastructure. The height of the luminaire is different, so the lighting needs are different for different purpose. And if you are seeing fast roads, the lighting infrastructure is different. That's where the electrical parameters comes. Also, the management of the faults are different, and for every municipality or every council, the operating times are different and their SLAs are different. So that's where all the challenges comes into deployment, and the deployment is more complex when we are doing. And the GPS location of the node or luminaire will be also recorded from the pole. Also, these controllers has a GPS chipset inside, and they also give the GPS location for fault management and easy troubleshooting. So that means they don't need to close the complete road to go and then do a repair work or do the maintenance work, but it is easy to identify in the field to go and then do the repair at the correct location. So with
Storm,
these
and Storm, yeah, looks like it's a complex operation, right? I think many of the installer, they've been installing streetlights for years and years, and they are not used to these IoT devices. It would be a big challenge if they are not properly trained, right? It's certainly not straightforward. Yeah, perhaps you can share further, right? What we have done, or what you have uh, done, right, to help all these installers in the deployment.
with our experience, Yong, so from last 10, 15 years, we have went ahead and then discussed these challenges with different installers and municipalities and councils, came up with a plug and play auto commissioning workflows, right? So these are more towards looking at how we can make it easy for commissioning, how we can detect these luminaires automatically in the field, also how we can get these electrical parameters in a easiest form so that they don't need to close the road the whole day to replace or make the street lighting work again. So I see many times many streets, by the time we see, okay, so usually we go to office in the morning and we see there is a street closed because they are doing some work, some street lighting work in the road, and they have to close the road, and many of them are inconvenient to do these operations, right? Also, it takes a longer time to do these works because they have to deal with the main supply, and they have to stop. In sometimes they have to stop to the homes also, and sometimes they have to stop only to the street lights and do these things, right? So we have come up with the easy operations. Okay, so automatic commissioning, so which means as soon as the installer does the installation of these luminaires, we do collect the basic information from the luminaire, and that is like an electrical parameter and also driver information. We collect that from the luminaire and then pass that information back to our central management system to start and trigger the commissioning process. Along with that parameters, we also detect where this luminaire is placed and which location it is and what is the street and what is the information. So the GPS information is there, and also the electrical parameters are there, so that the installer or a customer need not to upload any asset information from the field. So we collect them automatically and then fetch it from our backend system, so that it is much easier to do the deployment and commissioning of the street lights.
So it's like seamless, right? The installer who has probably no experience before.
We'll see with some example, right? So how this can be happened, right? So right now, if you are looking at RF or a UNB unlicensed technology, right? So it's a mesh or star technologies. So you can see the map here. Okay, we have done some study for these two these two different options. Option one could be, okay, the gateway is connecting up to 1,000 light points, and option two, on the right hand side, you have the gateway is a small gateway, and which is connecting up to 30 light points in a mesh network. So when we look at the city, we will not be able to make out how the city's infrastructure is built, because the expansion can go left, right, and center different times, and also city may have different natural infrastructures. May example, terrains, it could have parks in between, it could have subways in between, water bodies in between. Also, it could have long bridges, or the roads will be passing through in the cities. So even though our system is supporting one gateway to 1,000, but in this example, even though it is 8,000 light points, we are actually looking at 29 different gateways, because each gateway is not looking at maximum supporting, because of the infrastructure is different, because of the natural infrastructure is different for different.
The spread, it looks like to me, yeah, the spread is big, right? So for this location, I think we need a lot of gateways because the spread is big. It's a big area, and
You can see many places there are parks in this, and there are green areas in this. So those green areas are not connected to the lighting. So that's the reason we have to leave those green areas, so the spread becomes more. And we also looked at another infrastructure, which is going to be a controller which has gateway capability and at the same time RF capability together, and which is going to be 1:30. That means every 30 mesh nodes, they need to have to add one segment controller gateway node, which is coming around 273 gateways. Okay, and 273 catch points with the 150 meters distance far from light point to light point. Okay, so these are the complexities we have today to do and understand how the how the infrastructure, how the network can be. So this is where we do usually design and do a network planning before we do any deployment of large networks, the large street lighting systems, right? So with these complexities, we come to a plug and play with EasyConnect capability of RF mesh system. So that's where we also look at how we can do easy and seamless integration of the street lighting with the central management system. And in the Signify Interactivity, we come up with this EasyConnect architecture. This EasyConnect architecture is helping us to do a more easier deployment and more automated process of deploying the streetlights for a wider and large networks like in the previous examples, and even better than and bigger than um, bigger networks. So we actually evaluated with a couple of customers recently with this solution, and also we see it is a very cost effective solution. It's more than 30% cheaper compared to the existing solutions whatever we see right now today, and we are also saving a lot of labor efforts with this solution. And for 10,000 streetlight project, we see around 16,000 hours saved on the labor. And also we do not need to close down the roads. We do not need to do make more of maintenance works in the field. And the luminaire data, asset data collection is going to be very easy with this infrastructure. And we have the Signify system ready luminaires where their luminaire data, electrical parameter data is uploaded automatically into Interactivity application. So what it means is once it is powered on in the field, we read the luminaire data, driver data, and with the driver identifier, in the DALI world, we have the DALI 101 and 103 parameters. We read that information and ask our systems, can you help me out with the electrical parameters? Which means what is the luminaire characteristics? How many hours this luminaire can burn, and what is the wattage of this luminaire, and what are the different dimming types of this luminaire? All these electrical parameters are accessed through the factory and then automatically deployed into the field so that the commissioning is much easier in the field.
It's from here you showed the network that was simulated, right? Are you saying that for both of the options, we also need to have network planning done before installation? Is it that we have to do network plan?
So yeah, so this is actually much okay. So when you are looking at segment controller and the link node, maybe for segment controller we still need to carry out for the network planning, because it is supplying and making it 1:1,000 nodes as a capability. But for the link node, I don't think so there is a network planning is required. Maybe installer can do a small installation, like he can install 30 nodes, 30 street lights, and then just plug in one link node and then move on to the next 30 street lights and plug in one street light and move on.
So it's become very close to cellular, right? I mean, cellular, you don't have to think about anything, right? You plug in, the network from the mobile operators will be there already since it's cellular. So it's like, you don't have to think about how to do the network plan and so on, right? So this 30-to-1 with the RF mesh easy connect.
Yes, so which is very close to the how cellular is installed, but the installer needs to keep an eye on how his installation is going to be, right? So for example, he has assigned a job of 30 luminaires installation today morning, and then he went to the street and he saw, and these 30 he needs to install, and then he needs to plug in one link node and then move on. That's it. So he need not to do any network planning, design, or go with any complex jobs like for a segment controller, actually he needs to look at how the segment controller location and where the location of the segment controller, is it ideal for that, or is it good for 4G connection. All these things he needs to look at it, and it needs to have a 24/7 power supply for segment controller. For all these things will be washed out with the link node solution in the EasyConnect. Right? Yeah. So we move on and discuss about connectivity, how easy connection, link node, before link node how it is, and after link node what we are doing actually. So before the link node, what we used to do is we used to go with the mobile phone, right, with a hand, and then go to every luminaire and then collect the information. See here, the installer is walking to a luminaire, and then maybe some of you might have observed there should be some QR code somewhere on the pole or pole hatch. That's a unique identifier. Okay, he goes with the mobile phone and then go click on and then get that information and back upload to central management system, so that the commissioning will be triggered. But with the mesh node and the link node, this is completely gone, and then installer need not to go to every pole and then do the selection or do scanning of the street lights, right?
Right. But what about, so we spoke about the optimized way or the streamlined way of using EasyConnect for installation or deployment. That is the start of adoption of the smart street lighting system. But what about the aftermath, right? When there is a problem, there are some faulty ones, maybe there's a lightning strike.
So the replacements are still okay. So for example, I am in the city of very big city, and there are today morning I get a report. I have got maybe my 20 luminaires are failed, and these are my 20 different GPS locations, right? So those are in the 20 different streets, or it could be in one street, all of them together, right? So then we have a very easy workflow with the service tag, with the Signify service tag, which is an asset management tool. So once the installer has seen those GPS locations and the failures, he will get to know what are the assets he has a failures, and also he will get to know what type of assets and what are the troubleshooting mechanisms which are failed, right? So the serviceability of the street lighting becomes very easy with the Signify service tag, and you can see on the mobile. And as soon as he scans the service tag, he will get to know what is the product information, which location it is installed, and what accessories it has, and also when is the last installation, all this information with him. So it is much easier for him to order the spare parts, also order the maintenance activities from the service tag mobile app. Once he does the replacement of the spare parts in the field, he just need to scan 2 times of the QR codes, and then the rest is taken care with the CMS system. So it is having the old controller and the new asset, and it is automatically transferred from the old to the new with all the light management activities. So he did not to do anything much once he goes to the field and then just replace and then make this workflow much easier, right? So maybe there are some 6-7 steps he needs to do once he is at the pole, right? So he needs to log into the app and then scan the service tag, register, and then replace, and then trigger it so that the data is available in the CMS, so that it is ready to function the next day.
Seems we have talked through, right, end to end, I think, from the deployment to even the maintenance part. Any other evolution that is right now on the radar screen, if you could share further?
Yeah, so one evaluation could be, we are thinking of how we can optimize the system ready luminaire still, right? So today we are looking at MB1 data. Okay, so where it is DALI is providing a standard DALI part 251 memory bank. Okay, which is going to be an installer information, supplier information, nothing but supplier identification information also, which goes to the luminaire and the lamp configurations. So we are going and then looking at that details, so that we do not need to access our backend systems to fetch the luminaire parameters. We can functionally do it within the controller and then start operating the day when it is started installation, when the installation is happened. That one we are looking at it, but today all the manufacturers of luminaires are still not ready with the standards. Okay, it is the standard is getting matured.
So that is the data. That is the data that the manufacturer will upload into the luminaire driver, right? That we can capture, but we're not doing it because the quality of the data could be questionable. We don't know how accurate the data is, and not all vendors, also not all of them upload the data. So therefore, it is an evolution we can do, but right now there's still quite a lot of let's say.
There are a lot of installations missing with this data. Actually, we are collecting all the data and uploading it to Interact City right now. But we see many luminaires, this data is missing today still, right? While we are doing installation or deployment, we still see many luminaires, third-party luminaires are missing this information. Maybe Signify is one of the first ones to start following this, and this maybe slowly the standard will be matured and ready to be used. Along with this improvement, also we are thinking of how do we do testing of the luminaire itself, right? So as soon as the installer does the installation and he powers on the luminaire, what are the basic tests can be done and then report to the system, so that we know this luminaire is wired properly and it is also doing the dimming, it is doing all the circuits are correct, it doesn't have any short circuits, things like that. And the another part is the DALI communication and driver, lamp, and the controller communication is working okay or not. So these improvements we are looking at, and then further improving on the current solution, so that we have easy deployments in the future.
Great. Hey, thanks, Song. Thanks for sharing so deeply about what we have now and what we will be doing in the future. I think that is probably the last page on the topic today. But I think overall, smart street lighting it's still in its early stages, right? There's probably over 300 million street lights in the world. And at this point, roughly around 10% are smart. So there's still a 90% of these streetlights that are not yet smart. And of course, this easy deployment of smart streetlight would certainly help in the adoption and the conversion into smart street lighting across the world for the rest of the 90%. So hopefully, in a small way, as Signify, we can also help many of you who are online to make this conversion for your cities. So feel free to reach out to us, our colleagues around the world, if you are interested to look at the deployment of smart street lighting and any topics around this smart street lighting proposition, please feel free to reach out. I have a last page here about why Signify. I won't blow the trumpet too much, but certainly, again, we are a full stack world leader in lighting, and we are over 125 years. So certainly for public infrastructure, we will be here. We were there